Hello, today I will be talking about the final video assignment. My name is Brandy Milliner. This is Chemistry 1, and today's date is November 29, 2021. So first, I'll be starting with the state of substance. As you can see, there's three types of state of substance. There's solid, liquid, and gas. So with solid, you can see it how the little squares are tightly put together. There really is no space for them to go anywhere. They're all switched together, and when it's solid, it's like an example would be like ice, because you know ice is rock hard, it don't move or nothing. And then from solid, you could go to liquid when it's heated up, and it's more looser, and they can flow everywhere, but it still takes the shape of the object the water is in. Now, when it's heated up more, it goes to a gas. With a gas, it's everywhere. It's not put together. It's all just everywhere, just going crazy and just loose, and has space to just roam around. Now I will go to mixture. Now there's two types of mixtures. There's homogeneous and heterogeneous. So homogeneous is when everything is mixed together. You can see it's only one type of liquid or whatever else can be a homogeneous. Example would be, I would say milk, because when you see milk, you only see milk. You don't see milk and anything else. You don't see the broken down pieces. You just see the milk, the white creamy milk. Now heterogeneous, I would say, would be cereal, because you can see the milk and the cereal. You can see both of the components try to put together, but it doesn't mix. It's separated. There's the cereal and then there's the milk. Now with pure substances, there's two types of pure substance. There's an element and then there's a compound. So an element would be, like copper, hydrogen, lithium, nitrogen, oxygen, all them things separate. But with a compound, it could be 2, 3, 4 types of elements put together, like water makes H2O, which is 2 hydrogens and 1 oxygen. Now, the different types of units of measurements, I put temperature, meter, ampere, second, mole, kilogram, and candela. Now, for the prefixes charged, there are 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 10, 11. There's 12 types of prefixes. There is tera, which symbol is T, giga, which is G, mega, M, kilo, K, hecto, H, deca, DA, deci, D, centi, C, milli is M, micro is U, nano is N, and pico is P. So this goes from the largest all the way to the smallest. And these are the exponents. Starts from 10 with exponent of 12 all the way to 10 exponent to negative 12. So you could either go from smallest to largest or largest to smallest. With accuracy, there is, I would describe accuracy and precision as accuracy would be like depending, it's like when there's, like, I use the darts as an example. When it's closer to like the center part, these are accurate because it's where the target is supposed to be. It's all bundled up, trying to hit the target. But with precision, I would say it's more when it's put together, when they're all together, like the numbers don't differ from each other. They're all close together. So this will be accurate, but it's not precise. Because they are separated, but they're still on the target. Now this will be both because it's on the target and they're put together. They're all put together. Then this one would be precise because they're all together, they're all jumbled up, but it's not on the target, so it's not accurate. I'll be talking about the molecular shape. So there are 7 molecular shapes. There's linear, trigonal, planar, bent, trigonal, pyramidal, tehedral, octahedral, and trigonal biopyramidal. So for linear, there are 2 bonding pairs next to the element. Then for the trigonal planar, there are 3 bonding pairs and next to the element. And then for bent, there are 2 bonding pairs and then 2 non-bonding pairs. And then for trigonal pyramidal, there are 3 bonding pairs and 1 non-bonding pair. Then for tetrahedral, there are 4 bonding pairs. And then trigonal biopyramidal, there are 5 bonding pairs. And then octahedral, there are 6 bonding pairs. So next, I will be giving examples of the VSEPR theory. So for O3, there are 6 valence electrons for oxygen, and then there's 3 oxygens, so there's 6, 3, so that's 18. So then you do 3 oxygens, and then you put the valence electrons around them. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Now you see how each oxygen has 8 valence electrons next to them, so they're all full. So therefore, this will be a trigonal planar, and the molecular domain geometry will be bent. And then for ICL3, for iodine, there are 7 valence electrons. And then for Cl, there are also 7 valence electrons. And there's 3 of them, so that would be 28. And then you put the I in the middle. Then the Cl around it. And then you will put the valence electrons next to them, starting from the outside. And then you do the inside. And since iodine is in the P group, it could have more than 8, so it'll be 10. So it will be a trigonal biopyramidal. And the molecular shape will be T-shape. And then now I will do SeF4. So Se has 6 valence electrons and F has 7. And there's 4 of those. So it'll be 34. And then you put Sc in the middle. Then 4 F's around it. And then you put the valence electrons next to them, next to each F. And then 2 next to Se. So it will be a trigonal biopyramidal. And the molecular shape will be a seesaw. I will be going over a mole. So a mole is the amount of substance that contains the same number of entities as there are atoms in exactly 12 G. So the equation for a mole is 6.022 times 10 to the 23rd entities. To be able to find the molar mass, you will need your periodic table. So So at the bottom of each element, there are numbers like 55, 56, 11, 12, and so on. 7, 9, 23, 24. These are the molar mass. So if there is 0, 2, it will be 16 times 2, which would be 32. That's how you find the molar mass. To tell the difference between an empirical formula and a molecular formula, first you will start with the empirical formula. The empirical formula is just breaking down trying to find the molar mass for each the element, and then you will do, for each one, you will divide it by 1 mole divided by 23, 35, 16, which is the molar mass, and then you'll get these numbers. Then you will find the number that's the lowest and divide it by each one, so you could get the amount of that's next to the element. So in this case, there's 114, so the answer will be NaClO4 because there's 4 oxygens, because it has the most. Now, for the molecular formula, you would do the molar mass divided by the empirical formula, which will be you will use the molar mass number for this. So then it would be C, which is 12, H is 2, which is 2 H's, and then 0, 16. And then you would divide that number, the number you get, you would divide it by the whole 90.889, which is where you got this from, and then you would have 3. So 3 would be the molecular formula answer. Now I will be talking about chemical reaction. Chemical reaction is when 2 or more reactants come together to form a product, as in Fe and S, so that would be iron plus sulfur come together to make FeS, and 2 Na, sodium, and chloride come together to make 2 Na chloride. Here are 4 examples of everyday uses / household items. So first I have a grapefruit, which represents acids. I have bleach, which represents bases. I have salt that represents polyatomic ions, and I have a candle that represents organic compound.